Here we're going to look at how to graph a quadratic function in standard form. So we are asked how can you use key features to graph f of x equals x squared minus 4x plus 8. So step one, what we're going to do, so let's move that down a little bit. We'll write the steps at the end, but let's go through. So first we want to define our variables. We're going to define a, b, and c. Standard form would be ax squared plus bx plus c. So a in this problem would be equal to 1, b would be equal to -4, and c would be equal to 8. So we have a of 1, b of -4, and c will be equal to positive 8. Now that we've defined a, b, and c, we want to solve for x. And we're going to use our formula where x is equal to -b over 2a. So we substitute a and b. X is equal to negative, b is -4, and a is 1. A is 1, just color code this, and b is -4. So we get x is equal to 4 over 2, and x would be equal to 2. Now, before we move on, we want to make a point here. I want to make a point that x equals 2. 2 is the x-coordinate for our vertex. We did that in the previous example. But the x-coordinate of your vertex is also your axis of symmetry. So what we want to do with this x equals 2 is we're going to plot the axis of symmetry. We're going to go where x equals 2, and we're going to put a dotted line right along there. And I'm actually going to change the color so it's a little more visible. So we'll say x is equal to 2. So put a dotted line along axis 2. So we've now found the axis of symmetry, and that'll become pretty useful in a couple steps from now. But step 1 was to define a, b, and c. Step 2 was to solve for x, and now we're going to look to solve for y. So y is equal to x squared minus 4x plus 8. Right? We can take our function, the f of x, and just change that to a y. We now know that x is equal to 2, so we'll substitute our x value in, and then we can solve for y. So x will be equal to 2. We get 4 minus 8 plus 8. We get -4 plus 8, and y would be equal to 4. So that y being equal to 4 now gives me the y-coordinate of my vertex. So my vertex is 2, 4. And what I do is I plot that. So I'm going to go to 2, 4, and I will plot my vertex. So I'm going to keep backtracking and going through the steps. Step 1 would be to define a, b, and c. You then use a and b to solve for x, and then you use x to plot the axis of symmetry, and then use x to substitute into your function and find the y-coordinate for your vertex. Now, from here, we do need more points to actually graph our function, and to do that, you have a couple options. Quite similar to what we just did with this 2, where we plugged in 2 into our x value and then had an output of 4 that gave us the coordinate 0.24. You can do the same thing with any of your x values. So in theory, I could take like 3 or 4 or 5, plug it in as x, and I could solve for my y value, and it will give me a series of coordinate points. There's going to be an easier process, but one of the things you want to look at is that your y-axis is usually easiest to work with, and it's easy to find the y-intercept because every point along your y-axis has a coordinate, an x-coordinate of 0. So like here we have 0, 1, 0, 2, 0, 3, 0, 4, and so on. So what you could potentially do is you can take your equation and substitute a 0 in as your x value, and you'll find this to be the easiest number to work with because your ax squared and bx ultimately cancel out. Now the good news is you actually don't have to do any of this work, because if we do get a y-intercept of 8 here, what you might notice is that 8, this y equals here, is the same as our c value. So as a shortcut, your y-intercept is always going to be the value of c, because x will be 0, and the x squared and the minus 4x will effectively cancel out or drop out, and all you're left with is the c value. So you're given the c value of 8, that will be your y-intercept. So this step here, you don't actually have to do that step. Right? You can just jump right to c is equal to 8. So this is your y-intercept. So we've now plotted that. Now we do need one more point. You maybe more than one, but we'll just go with one to get a rough sketch. We have a point on the left side of our axis of symmetry, so we need a point on the right side. The axis of symmetry cuts your graph in half, and it makes it so the left and the right are mirror versions of each other. So what we can do is we can look at this y-intercept as being 2 units away from the axis of symmetry. So if it's 2 units to the left, if this is truly a mirror, which it is, we're also going to point 2 units to the right of the axis of symmetry. So that means if I have this point 0, 8, I'm also going to have this point here, 4, 8. So you'll mirror the y-intercept on the other side. And we could draw a very rough sketch of this graph. It's not going to be perfect because we don't know all the coordinate points. We could find more of them to make it more accurate, but we really just need a pretty rough sketch in this case. And that's enough for us to graph this. So let's go through the steps. Step 1, you're going to define A, B, and C. Step 2, you'll solve for x using your equation x equals negative b over 2a. Your third step will be to plot the axis of symmetry. Nope, that's not how you spell any of that. You'll plot the axis of symmetry, which remember is x equals from step 2. After you plot the axis of symmetry, you can then solve for y by substituting x into the function. You then plot your vertex, which you found from step 2 and step 4. Then plot the y-intercept, which is c. Or let's phrase that as coordinate point would be 0, c. And c being this point right here. And then finally, you're going to mirror the y-intercept across the axis of symmetry. Now, it might seem like a lot. There are 7 steps, but you'll see that those 7 steps are all quite simple, especially plotting the axis symmetry, plotting the vertex, plotting the y-intercept, and mirroring that point. So 4 of these 7 steps require very little work. Follow those 7 steps, and you'll have no problem graphing a quadratic function.